All right, it's 2:15. So what we're going to do today is our assignment. So the first thing I want to do is look at the our table of contents. So yesterday we actually did 2.1. We did 37 through 45 is what we were supposed to do. So we did that. So what we're going to be doing now is we're going to do 9:15. We're going to do reading 2.2. 2.2 is going to be pages. We're going to start at 43 today because we didn't go completely through what we needed to. And we're going to go to 51 today. So what we're going to be doing is we're going to be talking about acceleration. Okay. So the first thing I want to do is I kind of want to go over. Yesterday I did a PowerPoint, and that PowerPoint that I did yesterday, or better yet, excuse me, I used my overhead projector. I showed you how to do the math for the questions. And when I did the questions yesterday, I actually went through 38 through 42. So what I want to do now is I want to actually go over page 43, which is our reading assignment for today. And then what I'm going to do is I'm going to go through until we get to our practice problems on 47, and then we'll stop. And then tomorrow we will continue from those practice problems to break it up a little bit. Okay? So the first thing that we're looking at that is on my notes, which I'm going to use the board for. So the first thing that I have on page 43 is I'm going to say that velocity is not the same as speed. Now, when we're talking about average speed, we're talking about distance traveled over time traveled. When we're talking about velocity describes motion with both direction and numeric value. But velocity does, okay? So then when we're looking at, and it shows us velocity that is graph interpreted, you're going to have a graph where you have position versus time. Remember, you have your dry and you have your mix. This is your dependent y-axis. This is your independent x-axis. When we're talking about position, we're talking about in meters. And when we're talking about time, we're talking about seconds. So when we're looking at something and we're doing position versus time, and that is our topic or our heading. So when we're talking about that, we're going to look at the numbers that we have here. And where I am is I am in your textbook on page 43. And I'm going over the rest of the notes from yesterday that I didn't finish. 4.0, 8.0, 12, and 16. So when we actually graph this, we're wanting to find velocity average, okay? So to be able to do that, we're going to do our rise over our run, okay? So velocity average equals change in time change in position over change in time. When we're talking about change in position, we're talking about position final minus position initial. When we're talking about the change over time, we're talking about time final minus time initial. So to be able to do that, what you're going to have to do is you're going to have to take the beginning, that's your final, this is your initial, this is your final, to actually find the average velocity at that time. So that is a velocity time graph. Does anybody have a question about what a velocity time graph is? If you're good, raise your thumb. So I can see you say yes, I understand. All right, Hayden doesn't understand. Kind of, okay. Well, that's fine. You're going to learn before we get done. So that's velocity. If we're talking about position time graph, and this is being recorded, so you can go back and look at it if you need to, okay? So if we're talking about position time graph, we're talking about something that looks like this. Now we have object 1, object 2, object 3. Well, we're looking at this graph here. Object 1 has a constant positive acceleration. How do we know that for? It's because if you look at it, it's going up at a constant rate. Object 2 is at rest because it's straight across. Object 3 is at a constant negative acceleration. So when you're looking at a position time graph, you're going to look and see what's happening. If it's remember this is your axis here. If it's going up, it is a constant positive. It's straight across, it's at rest. And if it goes down, it has a constant negative acceleration. The other thing we want to talk about, instantaneous velocity. When we're talking about instantaneous velocity, we're talking about velocity of an object at some instance of specific point in an object's path. And the last thing from yesterday that I didn't cover is it may be the same as average velocity. So this might be the same, and it is okay. Do you have any questions from section 1? Because we are going to go into section 2. So what I'm going to do now is I need you to turn your mic on, those of you that are here. And please let me know if you were able to get on the digital textbook yesterday late. You were able to get on?
I was not able to get on.
I can't hear you.
Oh, I was not able to get on. My mic should be working.
You talking about
Hunter, do this or do this. This is yes, this is no. You were able to get on. Hayden, were you able to get on?
live yesterday? I can't. What was the question?
I don't think your mic's working.
How does that compete? Hayden, I can't hear you either. So
Did
it's
you hear me breathing?
I can hear you talking now.
There we go.
I wasn't understanding the question. Is you talking about the live yesterday?
What I was talking about, were you able to get on the textbook? Okay. So what I'm
no,
going to
ma'am.
do, I'm going to share with you my screen, and I'm going to step you through it.
Are you
Are you-
talking about the McGraw-Hill?
No, sir, I'm not talking about the McGraw-Hill. I'm talking about this textbook here. Okay. Is everybody ready? So what you want to do is go to Horry County Schools. Let me know when you get there.
Horry County Schools.
Yep, .net.
I'm here.
Hunter's there.
Yes, ma'am.
Aiden's, are you there?
Yes, ma'am.
Okay, so go to student and go to student learning commons. Now, you have to be signed on to your Google account, and you will have to be on Chrome to get this. Are you on Chrome, and are you logged into your Google?
Yes, ma'am.
This movie.
Fantastic. All right, so go to student learning commons, and it should take you to Clever.
Yes, ma'am.
Now, I made a link yesterday, so we're going to see if the link that I made is going to take you, and if it doesn't, I'll take you to the other one. So what you're going to do is you're going to go to my page. Are you there?
Yes, ma'am.
Okay. Do you see the sunshine little face that says Honors Physics?
Yes.
ma'am.
Click it.
Page not found.
Yeah, it says the same thing for me.
Yeah, and mine says that I'm on. So let's do this then. Let's go down and go to my page. And what you're going to do now is go down to where you see, do you see where it says My HMH? And if it's not in your favorites, keep scrolling down and you'll find it on Online District Learning.
Are you still on
I'm still on Clever. Yes, sir.
Are you on Clever? Okay.
I'm still on Clever and I'm still signed in.
All right. Yes, ma'am.
Okay, so if you go down to Online Learning, you will see My HMH.
Yeah, I'm there now.
Okay, click
Yes,
that
ma'am.
and see if you can get on.
It says hi Jordan Hutz, but it doesn't like show anything though.
It took me out, and it's like I'm re-sign in again.
Okay,
All right.
so you didn't get here.
Okay, I'm in here, but it says welcome to the dashboard. Hit start.
Hold on, let me try this again.
Okay, I'm stopping sharing my screen, Hayden. And what I want you to do is I want you to share me your screen.
I'm where I should be now. It says hi Hayden Enzer, just like it does Jordan.
Yeah, this
One of you show me your screen so I can see it.
is what mine shows here. It just says hi Jordan Hutz at the top, but has nothing.
It has
Nothing.
Physics 2017 Premium.
Okay, so that's what Jordan's looks like. Hayden, does yours look the same?
Jordan, can you slide your computer over, or like the screen over a little bit?
Do this.
Mine
Hayden,
has mine. How do I share it? Like, how do I?
Okay, so if you move your mouse around, you will see a little thing that says present now on the bottom bar.
Entire screen or what?
Entire screen, please.
And then go to
And once you present it, then you're going to show me what you've got.
You see anything?
Nope. Did you click the screen that was inside?
No, man. Do I click it? Okay.
Yep.
Here, hit share.
Yes.
All right. Yes, ma'am.
There
Can
we
you
go.
see it?
Yeah, we
You
can
got
see
it going on now. Good job.
Yeah. mine
Okay.
doesn't say that.
So you're on. Hayden Enzer is on.
Yeah, he's good.
So Hayden Enzer, do you see where it says student addition? Click on that, please, sir.
Student, okay.
Mm-hmm. And this is going to be your digital textbook that's going to come up.
Yes, ma'am.
So you got it.
I'm good to go.
So I got you on. So you can stop presenting and let's see what we can do for Hunter real quick. Thank you, sir.
All right, let's see.
So Hayden, while you're waiting for Hunter, this is what I want you to do.
You mean Jordan, right?
Yeah, I was wondering. I was like, she's called him Hunter like 3 times.
Yeah.
I said, yeah, I did call him Hunter, didn't I? Oh my
Yes,
God.
ma'am.
Jordan, please forgive me.
It's
Obviously, I
all right.
got your brother on my mind. Go ahead and go in your digital textbook and go to page 43, please, sir.
All right.
Hayden. So Jordan, what I want you to do is I want you to share me your screen, please.
Page 43.
I would have to because my computer stuff doesn't work very well, so I have to do this here so you can be able to hear me and see me. But I went to Clever, and I went to this one here.
Okay, so before you do that, go up to see what it looks like at the top
At the top.
of your computer.
It says chapter 2, motion in one dimension.
Yes, sir. Go to the right, Jordan.
Oh, my bad.
I'm trying to look up at the top to see if you're logged in or not.
Oh, yes.
There we go. So that is where you're logged into, and you're on Clever, correct?
Yes, ma'am.
Back up your screen, back up your phone for a few minutes. Okay, so when you go down, so you're going to go down to HMH.
Okay.
It's got it highlighted right there. Yep, click it.
Okay. And whenever I click it, it just takes me here to the screen and just nothing.
It's just a blank screen. Okay, refresh, please.
Okay. Yeah, same thing.
Yeah. So this is what's happening with you. It's still loading you. So go ahead and log out of there.
Okay.
And what you're going to do is you're going to follow along with me today. And I'm going to record everything so you can just do what I'm doing. And you came by and got your paper copy though, right?
Yes, ma'am.
So you're all go. You're all good. You just can't get there.
Yeah, I'm all good. I just can't get to the.
Fantastic. Okay.
So, Miss Sloan, what about the pages like 23, those that were due yesterday? What, do I go ahead and do them now?
So this is what's happened, Hayden. What I did yesterday is if you go on Google Classroom, you're going to actually see, and I'm going to share my screen again with you if you don't mind.
Okay. Yeah, I was confused about that a little bit.
That's fine. We can do it. Okay, so what I'm going to do is I'm going to go to my 4th block class with you. Can you see it?
Yes, ma'am.
Yes, ma'am.
Okay, so if you go to classwork, and if you go down to point 004,
I got that.
do you see that video?
Yes, ma'am.
Yes,
Well, that
ma'am.
video is everything you were supposed to do yesterday. What
Well,
I did is
I
I
had those pages. I was talking about like the 003.
Okay, so let's go and look at 003
Oh yeah, yeah.
because it might be something I need.
I did what that video. I literally had everything. I was like, dang, I didn't even I was sitting there practicing the problems and I had none of them right. I'm glad I watched that video there.
Okay, so
Read
the
and take
one
notes,
for
attach pictures here.
003, I don't even have anything attached to a.
No, ma'am.
Okay, well, I
That's what I
will
was
fix.
confused on.
Yes, sir. I will fix that today. So let me write this down. I will have that posted for 003. Leave here today. Will that be good, Hayden?
Yes, ma'am.
That would be great.
That way y'all can see it and y'all are good. Okay.
All right.
Fantastic. All right. So if you don't mind, what I want to do now is we're going to go on to the next section, which is section 2, chapter 2, section 2. All right. And what I'm going to do is I'm going to record the notes that I have, and then me and you and Jordan are going to go over questions, and I'll show you how to do the math. So this is what you need. If you have the digital copy with you, you can have it open. If you have the paper copy, you can have it with you. And like I said, this video is going to record everything I do today, and then you can come back and look at it. But I'm only going to do a couple of problems today. I'm not going to do all of them, and then you'll be required to do them, and we'll go over them tomorrow. All right, deal? Fantastic. Get my mask back on. So where I'm at is now I'm at chapter 2, section 2, on acceleration. Now, today, you only have to go to page 51. That's not the whole section. That's just something I wanted you to learn and see. Can you see everything? Are you good? Okay, so this is chapter 2, section 2, and it's about acceleration. So the first thing you want to have in your notes is you want to have the change in velocity equation. When we change it in velocity, that's called average acceleration. Average acceleration is an A with an AVG equals the change in velocity over the change in time. When you see this triangle, what this means is velocity final minus velocity initial. Change in t is time final minus time initial. Okay? So when we have that, and we're going to do a couple problems today on where we're going to try to find average acceleration. Besides that, they also tell us that ms over s equals ms times 1s equals ms squared. That is a conversion, okay? That's all that is. Make sure you have that written down in your notes. So what we're going to do now is we're going to go to page number 47. Are you there? Page 47 gives us an example. It tells us, sample problem B. It says a shuttle bus slows down with an average acceleration of a negative 1.8 meters per second squared. How long does it take for the bus to slow from 9.0 meters per second to a stopping speed? When you have these problems, what you're going to have to do is you have to write down your variables. We'll take this off. So the first thing that we look at here, it says a shuttle bus slows down to an average acceleration of a negative 1.8 meters per second. How long does it take for the bus to slow from 9 meters per second to a complete stop? So my velocity final and velocity initial. So if I look here, my velocity initial is 9.0 meters per second, and my velocity final is 0 meters per second, because it was going at 9 meters per second and it came to a stop, so its velocity final is 0 meters per second. Then it asks us, and it tells us that the average acceleration, so that is your AVG, my average acceleration is negative 1.8 meters per second, and it says that it's squared. We are looking for the change in time. That's what we're trying to solve. So what we're going to do here is we're going to say, all right, average acceleration equals, and that is the change in velocity over the change in time. Remember what I said. That is velocity final minus velocity initial time final minus time initial. So now what you're going to do is you're going to come up here, but we don't know what the time is. We don't know what the change in time is. So what we're going to have to do is we're going to have to put in what we do know. So if we look, we ain't got that. So we need to change this equation. So we're looking for change in time, change in velocity over A average. Means the same thing. So what we're going to do is we're going to say velocity final minus velocity initial over acceleration average. So the only thing we're doing now is plugging it in. Velocity final is 0 meters per second. Velocity initial is 9.0 meters per second. We're going to subtract those. And we're going to divide that by our average velocity, which is a negative 1.8 meters per second squared. So what you're going to do is you're going to take your calculator. And on your calculator, you're going to plug this in. Alpha Y, enter. We're going to have 0 minus 9.0 down.
Miss Long,
Yes, sir.
how do you change the mode, like, to get decimals in here? I got my calculator.
Yes, sir.
I got decimals, like the answers to stuff.
Okay, so let's look and see what mode you had yours in. So I'm going to go
I
my
still got
mode.
one,
My mode is normal,
when we were doing those
float,
practice
gradient,
problems.
fraction. So all mine's all to the left. Normal mode, float, nothing.
I got it normal, science, and then it's got English. I reckon it's E.
Yes, but you want to be in normal.
Normal, and then radian is degree.
And you need to be in radian, not degree.
All right, yes, ma'am. I was just gonna.
Got it? So let's put it in our calculator. You ready?
Yes, ma'am.
Y, enter. We're going to do 0 minus 9.0. We're going to go down to the bottom with a negative 1.8. And mine says that it's 5. Is that what you get?
To start off with, we got to plug in.
Yes, sir. So what you're going to do is you're going to do alpha Y.
Alpha Y, okay.
Yeah. Alpha Y, enter.
Yes, ma'am.
That gives you the fraction, right? You got a top blinking button, correct?
Yes, ma'am.
Okay. Then you're going to do 0 minus 9.0.
0 minus 9.0.
You're going to use the arrow key that's right over here, which is the gray arrow key, to get you down to the bottom. And you're going to type in negative, and you'll use the number that's underneath the 3, 1.8. And then you're going to do enter. What do you get?
5.
Yep. So it's 5.0. Why is it 5.0? Sig Fig rule.
It's supposed to be 5.0.
Yep. Your calculator is going to give you 5, Hayden. But you have, yes, sir. But you have to add the 0 in because of the sig fig. Right. And that's meters per second. And then you put a box around it to show me that's your answer.
Yeah, just like this paper copies got right here.
Yes. You're doing great. Okay. Now we're going to do question number 1. What I'm going to do is I'm going to take this and I'm just going to erase this for right now. And I'm going to get myself set up for my next problem, but I have to read it. So it says here, as the shuttle bus comes to a sudden stop and avoids hitting the dog, the acceleration uniformly is negative 4.1 meters per second as it slows from 9.0 meters to 0.0 meters per second. Find the time interval of the acceleration of the bus. So the first thing we're going to do is our A average is negative 4.1 meters per second squared. Our velocity initial is 9.0 meters per second. And our bus stopped, so it's 0.0 meters per second. What are we trying to find? Change in time. See? So we did this on our practice problem, didn't we? So the change in time equals the change in velocity over the average acceleration, right? We know that our change in velocity is velocity final minus velocity initial. And we know that the acceleration average is all we need there. So what we're going to do is we're going to plug in what we've got. My velocity final is 0.0 meters per second, right? Because that's what it says there. My velocity initial is 9.0 meters per second. And then my average acceleration is negative, right? 4.1 meters per second squared. I'm going to do the same thing that I did before. I'm going to take my calculator. I'm going to say alpha y enter. I'm going to do 0.0. And I'm going to subtract that by 9.0. I'm going to go down to the bottom. I'm going to do a negative 4.1 over enter. And what answer do you get? Got 2.195121951. Is that the number that you got on your calculator?
Yes.
Okay. So what is my number? Sig fig rule. Here's your number. What is my answer? 2.2.
It'd be 2.2, right?
Right? Second. Because we're talking about time, aren't we? We're not talking about displacement. So my answer is 2.2 seconds. Now I'm going to give you a few minutes to look this over and write this down before we go to the next one. I'm going to do one more problem, and then I'm going to let you go. And then what you're going to try to do is you're going to try to do question number 2. You're going to try to do question number 3. And you're going to try to do question number 5. And I'm going to go over question number 4 for you. This is question number 2. And that needs to be in your ISM book. Can you see the board? Kind of.
Kind of.
Okay. Can you see the board better?
If you can lift it up a little bit.
Yeah, just
I'll
tilt
lift
it
it
up
up
a little bit more. That's good.
Can you see it now?
Yes, ma'am.
Perfect. So what I'm going to do tomorrow is I'm going to try to do the projection and use my markers and my other thing instead and have a blue screen on the back, but it doesn't, you're going to be here tomorrow anyway, right? But I
Yes,
will
ma'am.
try a different type of thing to see what's going to work the best for you to see. Can you see it better?
Yes, ma'am.
Okay.
That's question number 1 on the The practice problems, right?
This one here,
Because that was the first one was an example, correct?
yes,
I was
you're
making.
exactly right.
I was like, those
Oh,
numbers.
sorry. Thank you, Hayden. Number 2 is kind of similar, just got different numbers.
Yeah, I was about to say.
Yeah, Miss Sloan. Woof. Y'all let me know when you're finished. Because number 2 is the same and number 3 is the same as what we just did. And I'm going to do number 4 for you.
I'm finished.
Jordan's good? Okay.
Yeah, I'm good too.
So we're going to do number 4 now. So on your paper, you look over number 4. And we're going to go over it together. Okay. So number 4 says, Turner's treadmill runs at a velocity of a negative 1.2 meters per second and speeds up at a regular interval during a half an hour workout. After 25 minutes, the treadmill has a velocity of negative 6.5 meters per second. What is the average acceleration of the treadmill during this period? So, what is our velocity initial, guys?
Has it been negative 1.2?
Negative 1.2. What's my units? Meters per second.
Meters per second.
Okay. What is my velocity final?
Be negative 6.5 meters per second.
Yep. What is the other number we've got?
25 minutes.
And what is that 25 minutes?
That's your time.
And that's my change in time.
Change
Right?
over time, my fault.
Change in time, right? So we don't even have to worry about doing the equation for time final minus time initial. It's already given it to us. So what are we looking for?
Average velocity.
Average velocity. Remember, it's AVG. Okay? Our formula for average velocity is velocity final minus velocity initial over change in time. I'm going to give you a couple minutes. So now what you're going to do is you're going to plug your numbers in, please, into your equation on your paper.
Plug it in the calculator. Not yet.
So you got your negative 6.5, subtract negative 1.2 meters per second, and you're going to divide that by 25 minutes.
These have to be in parentheses.
Nope.
Okay. 6.5. I don't know if this is right.
I don't know either. I think it is. Is it what you got, Aiden? I don't know if you can see it, but
Okay.
I don't know if I got mine right.
So here is the question. Here's the question. Meters, 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 meters. But is there anything to do with seconds?
no. Wait. You have to convert it, right?
Yeah,
Yes,
you have to multiply
because
that.
we have to have meters per second because we're looking for velocity average, right? Acceleration average, acceleration.
Yes, ma'am.
Average acceleration has to be meters per second, and we just had meters. All right, plug that in.
No wonder mine
Yeah, me too.
was y equals negative 6.5 minus negative 1.5, 1.2.
What did you get?
Ooh.
I got negative 12.72.
First of all, my first answer I got was negative 0.00353.
33333.
That
Yep.
I
was
got the
also
same
fine.
thing, Miss Long.
And I changed it. Yep, I changed it to scientific notation because I like it better. So go ahead and change your mode to scientific notation. This is a correct answer, by the way.
I got that.
Yes, sir, you did.
Yeah, me too.
So now change it to scientific notation now and tell me what you got.
I got negative 3.5. And then it's got all those 3 and then E negative 3.
Yes.
Yeah,
So
what you got on the
have
board?
3.5. We're going to take that off based on the sig fig rule, right? So I got 3.5 times 10 to the negative third power.
That's the final answer.
Either one of them are acceptable, but I would prefer this. What is my units? Meters per second. Right, guys?
Yes, ma'am.
Okay. So the only thing that you have left to do is you will have to do number 2, number 3, and number 5, and take a picture of it and put it on Google Classroom.
Yes, ma'am.
Make sure that you reread pages 43 to 45 on your table of contents. Say 9:15, reading 2.2, 43 to 51, and wherever you are. Now, you want to make sure that you've turned everything in. And then when you come tomorrow, be prepared. And Jordan will check again tomorrow to see if you can get your textbook.
Yes, ma'am. That'd be great.
Paper book, and we'll see. It's supposed to be linking over every night, so we'll see.
Okay.
That Hayden can get into his and you can't get into yours, so we'll just see. Any questions?
All right. For what we got to do tonight, we finished these questions, correct?
Correct, and that's it.
And that's it.
And you'll take pictures of the notes in class today that I showed you, and you'll take a picture of your math work, and that's it.
Sounds good.
Everybody good?
Yes, ma'am.
All right, I'm going to post this so everybody else can see it. And like I said in the little thing there, 15 minutes when the class starts, I'm going to do this every day. I personally think this is our best option, especially since you're going to be gone for 2 days and then you're here for 2 days.
It really helps.
And I'm probably going to do it even while you're here when I'm talking about it so you can have it online to look at. Or I'm just going to do what I did yesterday with the overhead thing and to use that instead. Okay?
Yes, ma'am.
About that tomorrow. Y'all are good, and I will see you later.